Welcome everybody to question 5, which is a 13-mark question. We'll start off with A, find dy over dx. Nice easy starter actually for this question. So let's take y, let's find the derivative of that, let's differentiate that. So we have y equals 6x minus 2 to the power of 3 over 2 to the power of 1.5. So let's differentiate that. So we're going to get dy over dx is going to be equal to just 6, because it's x to the 1. 1 times 6 is 6, and the x loses its power, so x to the 0 is 1. So then minus, so I've forgotten to put an x in there. Let's put that in there. 2x. There we are. So x to the power of 3 over 2. Let's times that 3 over 2 by 2, and we're going to get 3x, and then let's drop the power by 1. So instead of 1.5, it is just a half. And that is 3 marks. 3 very quick marks, I think. So let's move on. Question B1. Hence find the coordinates of the maximum point M. So here we go. If you look at M, we've found dy dx, which is the gradient of that line at any point. So you put any point in x and you will find the gradient at that point. So we want the point where the gradient is 0, because along that line M the gradient is 0. So let's put 0 in where x is. So we'll say that the gradient is 0. Sorry, not 0 where x is, 0 where the gradient is, and then we can find x and we can find the coordinates of the point M. So 0 is equal to 6 minus 3x to the half. So next step, let's add 3x to the half to both sides. So we get 3x to the half. 3x to the half is equal to 6. Then x to the half, let's divide by 3, is equal to 2. Now x to the half, little indices rule here. X to the half is the same as the square root of x. That's exactly the same. So the square root of x is 2. So if the square root of x is 2, then x is going to be 4. X is going to be equal to 4. So if we know that x is equal to 4, well, then we need to find out what y is. Let's go for y. We can use the original equation we got. So y is equal to 6 times 4 minus 2 times 4 to the power of 3 over 2. So let's work our way through that. So y is equal to 24 minus 2 times, now 4 to the power of 3 over 2. What we want to do here is go 4, then have this, the 2 here, the denominator, as our root. So the square root of 4, cubed. That's what we're going to do with that. That's how you do fractions as indices. So the number on the bottom as your square, so if it was a 5 on the bottom, then it would be the 5th root. As it is, it's a 2, it's the square root. So we've got 24 minus 2 times, now the root of 4 is 2, 2 cubed is 8. So 2 times 8, which is then equal to 24 minus 16, which is 8. So our coordinates for M, if we go back up here, our coordinates for M, that maximum point there, where the gradient is 0, is going to be 4, 8, because y is 8 there, and x is 4 there. Good, right, let's get rid of that, and move on to the next question. Let's get rid of that, and this here. So, the next question. Write down the equation of the normal. So, the normal is the line perpendicular to the tangent. So, if we draw a line across here, Try and make that roughly right. So that would be our tangent at the point M. So the normal is going to be the point that is, let me draw this out. The normal is going to be the point that is perpendicular. There we go. Not quite right, but perpendicular to that line. So goes straight through and cuts through that line. So what we can do there is 3 steps. We need to, number 1, actually no, we don't need to do 3 steps, we'll leave those 3 steps for later. This is quite easy. Because we've just got that one line going down as such, we've got that one line going down, that is just a simple x equals line, because x never changes going across there. And we just worked out that that point is 4, 8. 4, 8. So 4 down here and 8 up here. So if it's 4 down there and x never changes, the line is going to be x equals 4. Just a straight line across there like that. Now the next question, this is where our 3-point plan comes in. Our next question, we have a point P that lies on the curve. So find an equation of the normal of the curve at point P, and then give your answer in this form, blah blah blah. So point P is whatever that is, 9 over 4 and 27 over 4. Don't need to worry about that, but we are going to use the 3 points. We have to, number one, find an equation to the normal of the curve at the point P. So number 1, we have to find out, find the gradient at that point. So find dy over dx. So we want to know how steep the curve is at that particular point. So if we look at the graph, we want to know how steep it is. Then, number 2, we have to use that to find the gradient of the normal. To find the gradient of the normal. Okay, and our third point is to then put it in to y minus y1 equals mx minus x1. So our gradient of the normal, so this one here is going to be m, and y1 and x1 is going to be our point P, which is 9 over 4 and 27 over 4. 9 over 4, 27 over 4. That's going to be our x. That's going to be our y. So let's start off. Let's do find dy dx. Find the gradient at this point. So let's put in, we found the gradient dy dx, so we found that earlier. There it is. So let's put x in there. So 9 over 4 we have to put in there. So the gradient is equal to 6 minus 3x to the half. So equals 6 minus 3x to the half. Here we go. So we're going to put in 9 over 4. So this is dy dx, the gradient. Dy dx is going to be equal to 6 minus 3 times 9 over 4 to the power of a half. And of course, as we showed earlier, or as we used earlier, we can use that indice in another way. So we can go the square root of 9 over the square root of 4. We haven't changed anything there, we've just brought this inside here, applied it to both of these numbers, and instead of writing a half, we put the square root. So let's do that then. So minus. So root of 9 is 3. 3 times 3 is 9. And the root of 4 is 2. So 6 minus 9 over 2. 6 minus 4.5 is going to give us 1.5. 3 over 2. 3 over 2. So then we need to find out what is the gradient of the normal. If we go back to our plan here, use the gradient to find, use that to find the gradient of the normal, excuse me. So what we can do is we can apply it to minus 1 over m. So we can say minus 1, here we go, minus 1 over 3 over 2. If you do that, you end up flipping it and giving it a minus. So, in other words, take this, flip it over, and give it a minus. So flip it over to 2 over 3 and give it a minus. If it's got a minus, take the minus away. So that is going to be the gradient of our normal. Let's put it in to our equation for finding out the line. Y minus y1 equals mx minus x1. So let's put that in. So y minus 27 over 4. That's the y-coordinate of our point P up here. That's the y-coordinate there. And our x-coordinate is 9 over 4. So our x-coordinate is going to be 9 over 4. Do this. Here we go. And then our gradient of the normal is going to be this here. So minus 2 over 3, like that. And then it's just algebra, it's just timesing it out, it's just playing with it until you get it into that form that they asked for it in, rather. So y minus 27 over 4 is equal to minus 2x over 3 plus 18 over 12. So minus 2 times 9 is yes. So then we can simplify 18 over 12, we can divide both of those by 3 to get it into, oh actually, rather than do that, perhaps it's better if we get this one over 12 and this one over 12 as well. So y minus, what's it going to be, what's 27 times 3? 27 times 3 is 81, so 81 over 12, which equals then minus 8x over 12 plus 18 over 12. This is going to get quite fiddly to play with, but never mind. So then we're going to have y. Let's put these two together. So let's add 81 over 12 to both sides. So 81 plus 18 is 99. So y equals minus 8x over 12 plus 99 over 12. Then I think times everything by 12 and get everything on the left hand side. So times everything by 12. So 12y equals 8x minus, equals minus 8x plus 99. Let's put everything on the left. Last step is going to be 8x. Or do they want everything on the left, or do they want ax plus by equals that? So they want x and y on the left and our integer on the right. So 8x plus 12y equals 99. There we are. So that took a little bit of playing around with, but hopefully you got the idea that that's what we have to do in that 3-part method. So the very last question, I know this is a long question, but the very last question. So the normals to the curve at the points M and P, so the ones we just worked out. So the normal at M is x equals 4, and normal at P is that one that we just worked out down there, that 8x plus 12y or whatever it was. So those normals intersect at the point R. So we have two lines intersecting, and we want to find out where they meet. So that, to me, sounds like simultaneous equations. So x equals 4 and 8x, not 8x equals 4, 8x plus 12y equals 99, that's our number 1, and x equals 4, that is our number 2. So actually let's put x equals 4 into there. So you can do this however you want. I mean, I just think this is the easiest way. Maybe you have an easier one, but let's go x times 4 because 8 times 4 because x is 4, plus 12y is equal to 99. So then we can find out what y is, then we can find what x is, and we have our coordinates. So that is going to be 32 plus 12y equals 99. Let's take 32 from both sides. So we're going to get 12y is equal to 67. And then divide by 12 so that we get y is equal to 67 over 12. You can simplify that down. Sorry, you can't simplify that down. You can write it out as a decimal if you really want, but it's an improper decimal. It'll go on forever. So I'd leave it as that if you can. Right, let's find out what x is. So x is equal to, here it is, x is in there. So let's put our y in. So actually, good. It's good that we left it as a fraction because we can just times by 12 now. So 8x plus 67, 8x plus 67 is going to be equal to 99. So let's do 99 minus 67, which is 32. So 8x is equal to 32. And then by dividing by 8, we're going to get x is equal to 4. So we have our point where the two lines meet, which is going to be 467 over 12. So I don't think there's anything in that question that is massively difficult if you know what you're doing. And of course it sounds easy to say you know what you're doing, but everything in there was just little small steps, and if you understand the question, you'll be alright. So, thanks for watching, see you on the next video.